Yo, what's up? Me again.
Excuse me, Larry who?
I believe they actually call him Uncle Pleasant.
Okay, here we go. It's the big reveal. Ta-da! Not really. And yes, I know my office chair is shot. I don't bother replacing these things until they actually fall apart under me and I fall on my ass. So, EFD, I'm not replacing it yet. Anywho, what we have here, this is an 𝘗𝗵𝗵𝗲𝗄𝗏 brand air still knockoff. Over Christmas, I actually saw these things drop down to $55. Christmas is over, but I think they're still cheap. Last I looked, the black one is $68, and you can get this in white for I think $65. Pretty sure. Anyhow, they're cheap. And this has my Airhead controller upgrade, whatever, installed, which is this little spacer on the bottom and this little box, and that spacer, that's why these two are different height. You have to fit a solid state relay in the bottom of this thing, and the only way you're going to do that is to increase some vertical space. So that's why the spacer is in there. Why did I come up with it? Well, because the temperature control in an air still just sucks. It's absolutely atrocious. It's horrible. One of the little fanboys in, it's the Facebook group that's dedicated to Jesse Wilson's YouTube channel. It's like Chasers of the Craft or something like that. Saw this and said, well, that's a water distiller. You can't use a water distiller. And going, you freaking idiot. Do you understand how your still even works? You understand what the temperature control portion of it is all about? Apparently not. And the temperature control is why I came up with the Airhead. Here is the temperature control in an air still. This is also used in the T500 boiler, in which my case I just I took it out and I just connected the wires together because I'm controlling the temperature myself anyway. But you'll find these in everything. George Foreman grill, deep fryers, space heaters, anything. This is a 200 degree or 212 Fahrenheit or 100 degrees Celsius one. And the way it works is, as long as it's cool and under its set temperature, electricity conducts through it perfectly fine. Once it hits itself or set temperature, it cuts out. And that's why they call it a bang bang temperature controller, because bang, the temperature's on, full blast, bang, it's off. And it repeats this. Once it hits that temperature, it has to drop about 2.5 degrees Celsius before it will reconduct again. So you have these nasty, nasty swings. We'll just say that it's an approximate temperature control. It's nowhere even slightly precise. This is why I came up with the Airhead controller. Before I did this, I bought another brand of an air still clone. Don't remember what brand it is. I think I paid $70 or $80 for it off of Amazon. And I bought it because it had adjustable temperature. I'm going to turn that one on. Well, if I leave it turned on, it's easier to actually start. I have this one set to 80 degrees Celsius. I've had it running earlier because I wanted to get it preheated. Rather than using a snap switch, this one uses a thermistor, which is controlled to a little, or connected to a little circuit board, drives a mechanical relay, but it does the exact same thing. It gives me a 1 degree deviation rate that I can choose, but still it overshoots and undershoots by 2 degrees. This is set to 80. You'll see this actually jump up. I'll actually hear it click. I don't know if the microphone will pick it up. There, I heard it there. It clicked right there. Now the power is cut out, but you'll see this. It'll continue to rise. See that? Went to 81. It'll probably go to 82 before it starts falling. And it's because it had full power going to that heating element. There's a lot of turbulence. 82. There's a lot of turbulence in there. So that's why it continues to rise. The thermistor is not exactly a precise temperature measurement device, whereas in this one I use a digital temperature sensor. This will actually fall back down. In theory, it should turn back on at 79 degrees, but I often see it drop down to 78, somewhere in there, and then it just continues this. So while I set the temperature, the target temperature, to 80 degrees, the best it can actually do is 78 to 82. That's a 5-degree range. Yet another reason why I came up with this. So let me get this one warmed up. I got to add some warm water to it and get it started. Hopefully I can get the camera over here to focus on the display so you can see what's going on. But this solves all of the problems with the AirStill. And no, the AirStill Pro is not the next best thing. Have you looked at the price of those damn things? That's outrageous. The price is atrocious on those. It's for the amount you can get a My Vodka maker for way less than an AirStill Pro, and you're not limited to the 1 gallon capacity. So I don't care what the guys in the Jesse's little fanboy group say. No, the next best option is not the AirStill Pro. No. Get a My Vodka maker, or if you really want to build a normal still, do that, or get a T500 system. There are better ways of doing it, but no, the AirStill Pro is not the only way I would think that an AirStill Pro is really any use is if you live in a trailer, a camper. You don't have room for it. But no, they're not going to be your savior. If your goal is to make 190 proof lighter fluid, as I call it, no. Get a My Vodka maker, or just get a real still. Let me get this one set up. I'll be back in just a second, all right? Okay, I'm back. I added some warm water to this and I let it warm up to about 80 degrees Celsius and then turned it off, so it has a little bit of a chance to cool down so you can actually possibly see how it works. I know the camera can't actually show you everything that's going to be on the screen here. Maybe you can zoom with your phone. Who knows? Anywho, I wanted to show you what actually makes this different and better than anything that is available off the shelf. Because, well, like those guys in those Facebook groups, they you have these guys saying, "Well, I have a PID controller that works perfectly fine." It's like, no, you have a PID controller that doesn't do the correct job. Or other people saying that they just have an SCR controller that they hook up to the boiler. I'm going, great, but I mean, you have to set up a science project every time you want to use it. Everything here is all built in. You plug one cable into the wall and you're done. And as for the guy who has the PID controller, where did you put the temperature sensor? You certainly can't put it in the top or it'll leak and you'll never get anything out of your still. If you put it in the bottom, you constantly have like this little tether hanging off of it that you got to hook up to your PID controller every time. So yeah, nice try, but your attempt at diminishing what I've come up with, epic failure, I think is the proper terminology for that. Anywho, I'm going to turn this on and, well, here comes the hissing noise again. There, it's on. You'll see it takes a couple seconds to boot up, and it boots up that fast. Now, what makes this different is that we now have 3 modes. The first mode is constant power, so it doesn't manage any temperature at all. You select constant mode. You actually select the different modes with these up and down buttons. And then we're in constant power mode here. We would touch this one where it says power level. You can see it highlights so you know that it's selected, and you can scroll up and down. Like I have it set at 10% right now. If I press and hold it, it'll just continue scrolling like any other device. There, that's set to 40%. And then we have a start button over here. The one that says temperature is disabled. It doesn't do anything because we're in constant power mode. So we just touch that and it starts. So right now, it says my internal temperature is still 66.1 degrees Celsius. So in constant power mode, it'll just run forever until you decide to turn it off. If it boils out water, there's a safety feature in the code that will actually shut down the unit if the boiler reaches, I think, 203 C. It's 203 or 205, I can't remember, but there's a safety feature, so it won't kick the actual internal breaker that I had to eliminate by, I had to take the button out so I have a hole to get the wires through, so that will never kick. Even if you're boiling water and you boil it out, it won't kick. So I'm going to stop this. Our next mode, is constant temperature mode. And the way the temperature modes work in this, like right now I have it set to 80 degrees Celsius, 176 Fahrenheit. If I start it, what it actually does, it starts at a power level of 50%. And then every 30 seconds it adds 1% to that until it finally gets up to temperature, and then when it does, it falls back to a third of its power, which is 33%. That's when the temperature management kicks in. So it continually increases its power until it reaches its target temperature, then it does a fallback. If you look at the settings that are in the Boilermaker, you have a fallback percentage. So this one is set to fall back to 33%, and that's when the temperature management kicks in, and then it will slowly increase the power up to what it absolutely needs to maintain that. Now if you have your temperature set too low, like this is set to 80 degrees Celsius, I would assume, as many times as I've been through this, the power management will actually reduce it, because it doesn't take 33% power to maintain 80 degrees Celsius. It's actually way more efficient than that. But if you look at the way that works, or the original ones, they're constantly blasting full power through that boiler, or that boiler heating element, until it's up to temperature, then it shuts off. And here's the worst part. If you have suspended solids in there, and I know these guys in Jesse's little fanboy group say, well, Jesse never had that problem. Well, you know what? I bet you there's a lot of things that Jesse does not video record himself doing. This is basic physics. Physics applies to everybody. Doesn't matter how many YouTube subscribers you have. But if you have suspended solids in there, you have full power going, suspended solids, you cut the power, those suspended solids are going to fall, because there's nothing pushing them back up in the air. Well, in the original air still with the little, snap switch, those suspended solids fall to the bottom. You kick your power back on and bang, full power to it, those solids will actually scorch. I don't care what anyone says, Jesse had the problem. Take my word for it. His YouTube subscriber count does not defy the laws of physics. Sorry to bust your bubble. Alright, so I'm going to go ahead and stop this one before it gets too carried away. So the third mode in here is temperature controlled, but it's on a timer. I use this setting a lot. Like right now, this is set for 2 hours. The temperature starts at 80 degrees Celsius or 176 Fahrenheit, and progressively increases to 86 degrees Celsius or 186 degrees Fahrenheit. And it does this by increasing the target temperature every 15 minutes. So that whatever your range is here, you can pick your starting and ending temperatures as well as your time. But what it does is takes that range and divides it up by the number of hours and multiplies it by 4. So there's a change every 15 minutes. And the reason I do this is because, like I said, I had to do it with this one a lot. I would start it at 80, and then I would have to manually punch the temperature up until I finally got all of my ethanol out. Yeah, you could leave it at 80 degrees Celsius, but it'll just take longer. If you progressively increase your temperature, you're going to push that ethanol out a lot faster. So if I were to do gin in this, like load it up with a bunch of 80 proof vodka and botanicals and stuff like that, over 2 hours, it will push all of that out, and I will end up with 140 proof. These things are really reliable. They will deliver between 135 and 140 proof reliably with no special tricks involved. So that's the third mode. So I just started it. We're at 73.4, 50% power. It shouldn't take very long. It'll get up to 80C, and when it does, it'll fall back down to 33% power and begin its temperature management. And rather than the thing adjusting downward, if you're adjusting constant temperature, it's gonna adjust upward until we finally reach our upper limit temperature and have pushed all of the ethanol out. So that's what makes this thing a lot better. You have 3 modes. You have constant power, constant temperature, or timed with progressive temperature. I even put code in there in case you put the numbers in backwards, it'll start out high and work its way down. I just figured eventually somebody's going to do that just to see if it works and try to make a point. So I added the code in there to account for that. Haha. So that's the operation of this. I'm going to show you, if you aren't up to component level electronics work or 3D printing, or if you just don't have a 3D printer that's big enough to print the spacer ring, I have kits available on my website. They're turnkey kits. Let me get this out of the way and I'll be right back. Okay, right here we have the actual turnkey kit that I'm selling on my website. At this point in time, they are available. Keep in mind, I am not running an actual full-blown mail order service because I have 3 3D printers here. Only one of them is big enough to print the spacer rings. The other 2 printers that are behind the camera here are pretty much dedicated to printing Boilermaker cases. Each of these halves take 9 hours each to print. This takes another, I'm going to guess, a total of 8 hours for both parts, the front and back part of the case. So that's why I'm not doing a full-blown mail order service. If anybody else wants to build them and sell them, be my guest. It's open source. That's why it's open source. All of the models are available on the GitHub page. These are made by my friend James the Doc over in Ireland. He's the one who came up with the entire design, the spacers, the case, and everything. So there's a link to his YouTube channel on various parts of the GitHub page. I'll put a link in the description here, so if you want to go over there and tell him thank you, go ahead and do that. Please do. So here, this is the case that mounts to the outside of the air still. This is a touchscreen LilyGo T-Display S3. It's an ESP32 with a built-in capacitive touch LCD screen. 4 wires on a ribbon cable that connect to the power supply and interface board. These are currently handmade boards. I'm waiting to order the printed circuit boards until I need to order Raspberry Pi hats, the LiDAR hydrometer reader, and I don't want to just order 5 printed circuit boards. So when I go to order printed circuit boards, I'm going to order a bunch of each. But until then, the interface board, I guess I can pull these up over here so you can possibly see them. That's the interface board and power supply. There's the solid state relay. And there is the case for the ESP32. If that's set to 50% power, I'm going to go ahead and start this. So you can see, maybe, can you see that? Yeah, you should. The LED on the solid state relay is flashing. That indicates the power that's going to be sent to the heating element. These do not control the fan in the air still. I figure as long as the power switch is turned on, the fan is on. And if you don't want the fan running, you're obviously not distilling anything, just turn your power switch off. I would have added another relay, but I mean, that's just one more thing that has to be hooked up. And most people that I talk to are not real enthused about anything that has to do with wiring. So that's why I've simplified this. There's the temperature sensor, easiest thing to do with that. These come with a copper clip. When you take your snap switch out of your air still, you're going to have 2 bolts. Mount this into place of where the snap switch was. These just sit down on the little base. You run the wires through the front. You got to drill 2 holes for the ESP32 case. It comes with the bolts. As you can probably see, I put the bolts in the back there. The only bolt that doesn't come with it, you'll have, because I've found that these are all different, so I can't exactly just ship another mess of bolts or one or whatever. This actually uses 3. This one uses 1. It's a 70 millimeter by 5 or 6, I can't remember. It's on the GitHub instructions page. It says what you need if you have this one. But like I said, that's the only thing that a person will have to come up with on their own is the bolt, a longer bolt to put the bottom back on, because like I said, I can't provide them because I don't know what everybody's air still is going to require. I just know that they're all the same diameter. So that spacer ring fits. Anywho, look at the time. Yep, this is another one of those long stretched out videos. So I'm going to cut this off. I'm going to fill up the description with links. Like I said, if you want to order these, they're available from my website. There might be a 10-day lead time on them. It just depends on how fast people are actually ordering them and how fast I have to order replenishment parts to assemble them. But generally, if you order one and I have everything here, I can have all of the 3D printed parts done in a day and a half. I send them out by priority mail in the flat rate box, so you'll get it from 3 to 7 business days, insured and all that. So I think that's about all I have for this video right now. I'm going to cut this off before it gets even more annoyingly long. Sorry, it's just I have it. I don't know why. Anywho, have a good one. We'll see you the next time around. Bye.